Hello there, welcome to the October 2020 paper 2. Here we're looking at question 12. The curve shown in figure 3 has parametric equations x equals 6 sine t and y equals 5 sine 2t between 0 to pi by 2. The region R shaded in figure 3 is bounded by the curve in the y-axis, by the curve in the x-axis, show that the area of R is given by this expression here. So, the intersection between the curve and the x-axis is going to be when y is equal to 0. So therefore, sine of t will have to, sine of 2t will have to equal 0. 2t will therefore have to equal 0 and pi. So therefore, t is equal to 0 and pi by 2. So there's your limits. So it's going to be between 0 to pi by 2. Now it's going to be the function y and dx by dt, and then we can write the integral with relation to dx. So with relation to dt actually. So it's going to be the integral between the boundary of 0 to pi by 2 of the y function, so that would be 5 sine 2t, and then dx by dt, which would be times 6 cos t dt. So if we now rewrite this as a double angle formula, it's going to be pi by 2 to 0. 6 times the 5 will be 30. And then the double angle formula will be 2 sine t cos t. And then it's going to be times by cos t, because I've already multiplied the 6 at the front with the 5. And let's then expand the brackets. So it's going to be from 0 to pi by 2. 30 times 2 is 60. Sine times cos times another cos will be sine t cos squared t dt. And there we are, that's the answer for this part A here. Let's now move on to part B. Hence, show by algebraic integration that the area is exactly 20. Now, how are we going to be doing the integration by substitution here? We're going to be doing it, we're going to be doing it by substitution of u equals cos t. Now, the first thing I'm going to do here is work out what my limits need to be. So when t is equal to 0, u is going to equal 1, and then my other boundary will be cos of pi by 2. Cos of pi by 2 is 0. So actually the integral is going to be in between. When I substituted in 0 I got 1, and then when I substituted in pi by 2 I got 0. So actually my limits are actually the other way around, but we don't need to worry. It's a region R we're looking for an area, so even if we get a negative answer we can just say therefore the area is positive. Okay, so not to worry about the 0 and the 1 being upside down. We can always swap it around, we can always work out and give it in relation to the area later on. But now we're going to substitute in u equals cos t. Now we need something to replace the dt with, so du by dt is going to equal minus sine t. And let's rearrange this a little bit. Dt is going to equal minus 1 over sine t du. Okay, so I've just rearranged that a little bit, times the dt on the other side, divide by the minus sine t onto the left. So it's going to now be 60 sine t u squared, because cos is u, so it's u squared, and then times by dt, and dt is minus 1 over sine t du. So now actually there's a little trick to do with the limits. Now you can swap the limits over and move a negative to the front. Now I've already got a negative to the front, so actually this is going to be equal to the integral between 1 and 0 if I cancel out the negative there. Cancel out the sign on the top and the bottom there, so now it's just 60 u squared du. So the little trick here was to swap around the boundaries here, but when you swap around the boundaries, you're going to be subtracting them in a different order, so therefore you'd need to factorize a negative to the front, but I've already got a negative here, so that would just be a double negative, so now it's positive. So now let's integrate, so it's going to be increase the power by 1 divided by the new power, so it's now going to be u to the power of 3 divided by 3, so that will now be 20, between the boundaries of 1 and 0, substituting 1, substituting 0 and do the subtraction, so that equals 20 exactly. Lovely, so there we are, that's the answer for part A. Let's now move on to part B. So we've now got part of the curve is used to model the profile of a small dam used in figure 4. Using the model and given that x and y are in meters, the vertical wall on the dam is 4.2 meters high. There is a horizontal walkway of width mn along the top of the dam. Calculates the width of the wall. So what I want to work out is what the t values are going to be for this height of 4.2. So I now need to set the y value equal to 4.2. So therefore 5 sine 2t is going to be equal to 4.2. Let's first divide by 5. So 4.2 divided by 5, which would be 0.84. Let's now undo the sign on this in radians mode. So it's going to be, let's just change my calculator back to radians mode. Sine inverse of 0.84. Sine inverse 0.84 is 0.997. And then there'll be another solution if we do pi minus this answer, pi minus answer, which would be 2.14. In fact, let's just save both of these values on the calculator as A and B respectively, so we get really accurate answers. So we'll do that one first. Sine inverse 0.84. We'll save that as A. And then we'll do pi minus answer and save that as B. Okay, good. So we've saved it as A and B. So therefore, oh, actually we need t, don't we? So now A is going to be divided by 2, which would be 0.4986. 0.4986. I'll now save this as my value for A, actually. So store that as A. And then with B, I'm going to divide that by 2 and get 1.07. I'm now going to store this as B on my calculator, so store as B. Right, so now we need to work out the horizontal, so we need to work out the width of the wallway, so now we need the x values for these two different values of t. So it's going to be x equals 6 sine of 0.4986. Now that's A in my calculator, so I'm just now going to write 6 sine A in my calculator, and that will give me the answer as accurate as I possibly can make it. So it's going to be 2.87 meters, and then the other x value is going to be 6 sine what's it going to be? 6 sine 1.07. So that's just my value for B in the calculator at the moment, so I'll just change my A for a B, and I get 5.27. So therefore the width of the wall, width is 1 take away the other, so it's going to be sine, yes, so we'll do answer minus 2.87, but I'll probably write it as 6 sine A, 6 sine A, always looking to get my answers as accurate as I possibly can, and that gives me actually exactly 2.4. Even when I've used these super accurate answers here, the width of the wall is 2.4. And there we are, that's the answer for this question here. So that's 11 marks here for question 12. Let's now move on to question 13.